So let's see how we would do all this in Python. So this is how we write a class in Python. This is what a class structure looks like. So we use the class keyword. So this is one of these reserved keywords that you can't call something else. You can't call a variable class because that word is reserved for classes. So to declare a class, we use the class keyword. And then we give the name of the class. And my apologies, I don't know why I used camel case there, but there we are, I did. So at least you get a glimpse of camel case. But crucially, whenever we name our classes, we must make sure that the class name starts with a capital letter. Okay, so capital letters, you'll see in most things in Python, lowercase starting letters, but classes start with a capital letter. Okay, so here I've just called it, not very imaginatively, my class. Then I use a colon, and then as with functions and loops and conditional logic, we then have the body of the class that's indented by a single tab. And this represents the class definition. So this is all the stuff that then makes up a class. This, well, I'll come back to this. Let's look at these things one by one. So let's start with this first one here, because it's the weird one, but is in some ways the most important one. It's the one to wrap your head around. So this, the one that starts underscore underscore init underscore underscore, that is the constructor. Okay, so you'll see it's defined in just the same way that you would define any function with the def keyword to define a function, just as you've seen last week. This is our constructor method. Now that constructor method is automatically called whenever we say that we want to create an instance of this class, i.e. we want to instantiate. As again, this is the idea of this constructor is to assemble our object from a class blueprint. So in this example here, ignore this self bit, I'll come back to that in a second. So you can see it's passing in some inputs into the method, into the function, exactly as you've seen with functions normally. And then what it's doing here is it's then assigning whatever values are passed in to the attributes of this class. And it all comes back to this self word, which I'll talk about in a moment. So essentially what we're doing here is it's setting up, it's saying, when somebody creates an ambulance, I'll need them to pass in these two things. So you say, I want a new ambulance, and here is the registration number, and here is the trust. And here perhaps is where they get assigned. So say, okay, I'll now store that as the registration number for this ambulance, the trust for this ambulance. Now, just a word on this, you're maybe wondering why it's named in a slightly weird way with a double underscore, and it is two underscores in succession, both before and after the name. It's known as, in Python, as a dunder method, dunder being double underscore. And basically these are also referred to as magic methods. Don't worry too much about them. They're basically special methods that are called when they are needed. In the case of the constructor, they are called when you ask for a new object to be created from that class. And then this method would be automatically called. So that's why you see this double underscore here. Okay, so we need to talk about self, which you just saw in the previous slide. Self is incredibly important in trying to understand object-oriented coding in Python, but it is a bit weird to wrap your head around. So I'll try my best to try and explain this. So basically, self is the thing that stores the instance of the class. So in other words, if you think about when you create an object from a class, from the blueprint, self is the thing that stores that copy of it, stores that instance of the object. And whenever we define any method within a class, we always put self as the first input to that method. So if you have a look back here, here we've got the constructor, and the first thing we've passed in is self. In other words, this is the copy of the this will store the particular instance that we create. Even where we have methods in our class that don't accept any other input, we always have to put at least self. So even if there's nothing else, we still pass in self. And what it basically does by doing that is it says to run this particular method on this instance, i.e., for example, on run this method on Dan's ambulance or on Sammy's ambulance. So we always put in that self keyword when we write a method definition as the first input. However, this can confuse people a little bit. When we call the method, so when we've created the object and then we tell Dan's ambulance to drive, we don't pass in self when we call that. We just pass in the other inputs as though self isn't there. That's because Python will deal with self itself. So self is just there to store that particular copy of the object, if you like. Now, similarly, whenever we refer to something that belongs to the particular object, to a particular instance of the class, we use dot notation and we say self dot. Okay, so and that's what that's basically saying is, give me this thing that belongs to you, you as Dan's ambulance. So give me the attribute value that you as Dan's ambulance is carrying, or run the method that Dan's ambulance has. So rather than referring to the class, it's referring to specifically this instance, this copy of the object. And basically that's what self is doing. It's by using self, we're referring to that particular instance of the class, the individual object, rather than the class blueprint. And I promise you, this does make a bit more sense when you see examples. But here, if we go back to the constructor, what this is basically saying here is so if we look at the body of the constructor method, this is saying that when you create an instance of this object, it's the attribute 1 that belongs to you, set that to whatever value is passed in. Attribute 2 that belongs to you, set that to attribute 2 that's passed in. Okay, this will make more sense, I promise. But it is a bit weird to get your head round at first. So we touched on this a little bit, but just say we would potentially have other methods that a class has. Every class has at least a constructor, but we'll probably have some other methods as well, though it doesn't have to. And as you've seen, these work in exactly the same way as any other function, except that we have to pass in self. We have to pass in that copy of the object as the first input into the method definition, even if there are no other inputs.